Afternoon, students. Welcome to my class. I'm Suji Elizabeth George, your chemistry tutor who is from Kochi. I'm a postgraduate in chemistry, as you know. You have been seeing my earlier videos. So we have been studying a chapter called Metals and Non-Metals from class 10 CBSE syllabus, right? So in that chapter, we learned that metals have certain physical properties which makes them ductile, malleable, hardness is there, sonorous, lustrous, and all those things we have learned. Then we dealt with its chemical properties. Metals reacted with different reagents like oxygen and then water, then acids, and then it reacted with salt solution, other metal solutions, and we also know that why do metals react, or why does an atom react, or why does an atom combine with each other. We have studied in class 9 about it. An atom takes part in a reaction so that it want to attain a stable in electronic configuration. That is, it wants the number of electrons in its outermost shell as 8, which is the electronic configuration of all the inert gases. These inert gases like helium as 2. So hydrogen has the tendency to make 2 electrons or in its outermost shell. Then lithium also does the same, all those things, right? And again, other elements like carbon and boron or sodium, for in that case, they wanted to make the same electronic configuration as the next inert gas, the neon. Okay, so for that, it combines with other elements to form a compound. And their compound are of two types. We have learned about that as well, ionic compound and covalent compound. In ionic compounds, the metals share, or the non-metals, the elements basically shares, it gives out their electrons to the other one which is in need. So mostly metals are the ones which gives out the electrons so that it can attain the electronic configuration, and non-metals are the ones which takes in those electrons to attain electronic configuration. So that is why metals or elements combine with each other. So after all these things, we have learned about the reactivity series and all. Okay, so I hope everything is clear with you. Now we have reached another branch of chemistry which deals with the extraction of metals. Okay, so for daily life use, if you get up in the morning, you will be going to the washroom. You will be opening a tap, right? To wash our face, brush our teeth and all. So from the first moment, we are dealing with something which we have learned now, right? A metal. That tap might be made of a metal iron, or it might be made of a copper. So, or a mix of an alloy, anything it can be, but it is a metal. So we use it as a bathroom accessory. So while we go down, we want to have tea in the kitchen. Our mother will be making so many other things. She will be preparing breakfast and chai and tea, chai and coffee for everyone. So what are the things that she uses in the kitchen? Yes, all the bowls, vessels, the stove, everything that you see there in the kitchen is mostly made up of metals. And where do you get these from? Yes, of course, we go to the shop and buy it. So where do you think the shopkeeper will get these from? Yes, there will be factories which makes like Hanna aluminium factory is there, makes all these utensils. There are other steel factories there. Again, they do make these utensils, right? Yes. Where do they get the raw material is what we are going to learn now. Where do you get the raw material? Of course, our Mother Earth is a treasure of resources. It contains a lot of minerals, that is, metal salts are minerals. Minerals and all those things are present on our Earth's crust or somewhere below. So we need to find it out, take it out, and then remove remove the metal from those impurities, and finally we will use it. And that whole process, it is actually a very complicated process, but that whole entire process of extraction of metals and refining it into pure metal, all those things come under the branch called metallurgy. Okay, you can see there people working at a very high temperature, or you can see fire, red hot things are there. So they are working very hard in an extreme environment, right? Hats off to those people who are helping us to extract these metals, okay? And that branch of chemistry which deals with the extraction of metals, purification of metals, is known as metallurgy. Okay, so metals are found, hope you can see my slide. Metals are found in nature in different forms, okay, mostly mixed with other substances. And to use them in our daily life, we must extract them from their ores and purify them. This entire process is of extracting, refining metals is called metallurgy. So definition is that metallurgy is the process of extraction of metals from their ores. Refining them for use is known as metallurgy. And what are ores? So I mentioned the name ores 2 times over here. Yeah, from their ores over here. Yes, what is ore? I already told about minerals. That is metal salts. What is metal salts? What are salts? Yeah, of course, if you take a metal called zinc chloride, obviously it is a salt. Zinc carbonate, it is a salt. Then another one we can say is MgS, magnesium sulfide, zinc sulfide, all are mineral salts or metal salts. And if you want to extract zinc, we have to go around and find out which is the mineral of the zinc which is abundantly present, or a maximum we can collect. And so that what is our idea? We want to extract the zinc. So whatever it is present in abundance, whichever mineral which is present in abundance is checked, and then it should be easily available for us. Or finding out and digging, if it is mining, doing it, it should be easily available, and that means it should be affordable. That process of finding that or taking it out should be easy, affordable. Then we can consider that mineral as its ore. Okay, and if the extraction is easy, if the whole process is easy and affordable, then the whole process of removing the metal from a particular mineral is easy and affordable, then we can call it as its ore. Okay, so there are three main steps in metallurgy. One is the enrichment of ore. Okay, another name called is concentration of ore. Enrichment or concentration of ore is the first step. Okay. Now we will just learn it as removing the impurities. Obviously, we are going to mine or we are going out or the fields and we will find out which mineral we are going to dig, and then we will be digging that site, loading it. And while we are digging, obviously it is mixed with sand, it will be mixed with other ores, so many other impurities. And first process of metallurgy is to remove the impurities. Okay. And then comes extraction. First step is enrichment, then comes extraction or converting ore to metal. And there are certain processes that this ore undergoes before it is being converted to the metal. And those are called roasting, calcination, and reduction. And after that, we have to learn how, after extraction of this ore to metals, we have to learn how we are going to refine it. We need pure metal. So gold and all you need, you know about the purity. 24 karat gold is the purest. Then comes 22 karat of gold. Then you have heard of 916 gold. These all are how the purity is determined. 99.9 percentage pure gold is the 24 karat gold, and in 0.1 percentage still, or 0.01 percentage is still, sorry, so 0.1 percentage is still there will be impurity. Okay, so for impurity we use a method called removing the slight impurities that are present in the metal. We use the method called refining, which is based on electricity or electrochemistry or electrolysis. Okay, so these are the topics or subtopics that we are going to learn in this session. Okay, now we are going to see a beautiful slide. Yes, see how beautiful. You can see some crystals, some stones, which different colors, it is shiny and all. So if I say these are all ores of different metals, will you believe me? Yes, of course you have to believe me because it is true. Okay, so here there is one in pink in color, one nice blue in color. I don't know what all color, so beautiful, and I was so excited to see these different colored gemstones actually. And this somewhat very nice pink, right? Some are pinkish, some you can see it is reddish is there, green color is there, violet color is there. Okay, so let's see the metals and their common ores that we use for its extraction. So first one, let us talk about copper. Copper, two types of ore is taken, mostly three types of ore has been taken for copper. And first one is CuS. Cu2S. Here, yeah, you need to write it Cu2S. So Cu2S is called as copper glans, or it is a sulfide ore, a mineral of copper with sulfide. Then malachite is there, copper carbonate. Copper carbonate is actually the green one. Okay, so carbonate ore. Then about zinc. Zinc also have got two ores. We can extract zinc from zinc blende or zinc carbonate, which is the calamine. Have you heard of calamine lotion? When you have itching, we used to rub For etching, it is very good for using zinc carbonate, okay, which is calamine. So calamine is also an ore of zinc. Then comes aluminium. We don't have to learn aluminium in this class, but its ore is called bauxite. It is an oxide ore of aluminium. Okay, then calcium is there. Calcium's ore is calcium carbonate and calcium sulfate. Magnesium ore is magnesite and dolomite, which is carbon ore and double carbonate ores. Then comes mercury. Mercury is something that we need to study in this class. Mercury ore is called cinnabar. Remember all these names, say copper glans, cinnabar, zinc blend, all these things. And it is HgS. It is a sulfide ore. Then sodium, potassium, usually you get it as NaCl. You have known about it. And also potassium has, you can see it, KCl. Along with MgCl, it is present in carbonylite ore, that stone. It is a halide stone. And iron is hematite is there, magnetite is there, and iron pyrite is there. But you know what magnetite is? Fe3O4 is actually, this is the magnet that we use, no? It is magnet itself. Okay. So before going into extraction and all, we need to learn something which is called the reactivity series, and the extraction of metals usually is based on its reactivity. How these metals, I have already said that there are different methods of extraction of metals. Calcination, roasting, and reduction is there. So which metal we will be deciding which type of extraction is being used. So for that, we need to know the reactivity of each metals. Okay. And before going into that, let's see. So, okay, we will be studying about reactivity of metals. This series we have studied earlier in this chapter only. So, I have told you a mnemonic that is being used by me so that easily I can find out the reactivity series. That was, please stop calling me. You might be wondering why I'm saying it again and again, because I want this to get registered in your mind. This reactivity series is not only important in this chapter, it is important if when you study displacement reaction or double displacement reaction, then electrolysis, all these things. This reactivity series is very important. Now, please stop calling me cute zebra. Okay. I like her. Call me. Call me. Yes, I like her. Call me a smart guy. Okay. So please means potassium. Then comes sodium. Calling calcium. Me magnesium, aluminium, and there is carbon in between, but we don't usually take carbon into account. Then comes zebra, zinc, iron, I, like, lead, her, oxygen, copper, coal, mercury, Me, mercury, silver, Ag, okay. Call me smart guy. Silver is silver smart, silver guy, A, gold, and we will write platinum as the last one. So this is the reactivity series: potassium, sodium, calcium, magnesium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, and platinum. So according to the reactivity series, we can say that these metals like potassium, sodium, calcium, magnesium is present in more or less all types of salt is present. Its halides are present, its oxides are present, carbonates are present, sulfates are present, sulfides, nitrates, all of these which is in the top is present because they are highly reactive. They wanted to make compounds with other non-metal items, right? They are very reactive. We see that they occur in, obviously they will be occurring in compounds. They won't be found as in this free state. That is potassium we will not be finding in free state unless we store it in kerosene. Okay, so first five we can say as highly reactive metals, and all the compounds will be occurring as compounds. All the metals will be seen as in its compound. And then comes the moderately reacting metals, that is zinc, iron, and lead. Zinc, iron, and lead. These also occur in their compounds, but they are a little difficult to find, but still they are there. And extraction of this one, which is present in the highly reactive series, and the extraction method used for the second and the third and the last one will be different from each other because of its difference in the reactivity. Okay, then comes, this was moderately, then comes less reactive metals like copper, mercury, silver. Again, they are found both in compound states and free states. That is, we can see copper as copper itself, copper metal, silver also present. And then last is the least reactive. So the silver, copper, and mercury, they both they can see in sulfides, carbonates, and also as its metal itself. Okay. Then there is less reactive or least reactive metals like Au and platinum. Au is gold, which they both are found in free state. You just need to purify the metal before use. You see the process of electrolysis. Okay. Now, we are explaining this process just as an introduction, what is what and all. Hope you can see the slide clearly. So first step, as we said, is enrichment of ore. So we have studied in 9th standard about the physical properties of things, mixtures. So in a mixture, there will be different components. They do not form a chemical bond. They are only mixed with each other. Okay, they will not be forming any bonds between. They're simply mixed, and because of that, to separate them from the mixture, we need to use some physical methods. Okay, like physical methods that we have studied was filtering. Then we used magnets. For if you want to separate a magnetic substance from a non-magnetic substance, just if they are mixed, for example, sand and iron filings are mixed, we need to bring a magnet near it, and the iron filings will be attached to the magnet, and thus we can easily separated. Then we used decantation, all those filtration, distillation, funnel, separating using funnel, all those things, all these separation methods, physical methods of separation depended upon the physical properties, whether it is a magnet, whether it is weightless or highly, whether it is insoluble in water or soluble in water. All these things were considered, and a suitable physical methods were used to separate each mixtures of ores that we found in Earth's crust. Okay, so methods used here is that sometimes we used to use hydraulic washing. That is, depends upon the gravity. That means if any object has, if you take an ore and it also contains something which is lighter than the ore, we use this hydraulic washing method where gravity separation is involved. Again, if there is difference in the density, for example, if you want to separate butter from curd, we will be diluting the curd, make it buttermilk, and then what will we do? We will be agitating it. We will be putting it in the mixer grinder, or we will be using beater, so that we will be making it froth. Okay, we can see that butter will be rising up. And we will be collecting butter from top of the buttermilk. So the method uses high speed rotation. Okay, or we can say that we are applying air into it or agitating it, if you say. So froth flotation is some kind of that kind of method when one product that is there present is immiscible with the other solvent. Okay, so if you have some sulfide ores, they have said sulfide ore is there, and some other ore is there, or impurities is there. These impurities might dissolve in water. And we are taking two solvents, say that one is oil and one is water. If the impurities get dissolved in water and sulfide is dissolved in oil, and you know the difference between the densities of oil and water, where will you find oil? Above water, right? So some more thing, agitation, we will do some froth flotation, a method where we pass high speed air into substance. Whatever it is, you need to agitate it. What happens is that the impurity, or in the other way around, sulfide will be mixed an impurity, or which is mixed with oil will be collected up and we can separate it. That is the method. And here in this class for you, you don't need to learn all these things. I'm just mentioning it. So can you tell me where we use this magnetic separation usually? Magnetic separation is used when one material, one ore will be magnetic or another will be non-magnetic. Then we will use a method called magnetic separation. Okay. Now, extraction of metals, I already said. Extraction of metals depends upon the metals reactivity. And also, so highly reactive metals, as it is mentioned over here, the highly reactive metals like potassium, calcium, sodium, calcium, magnesium, and aluminium. What is used for extraction? What method is used? It is very difficult for normal separation. So if you want high energy, if it is, we need high energy source for the separation of the product, we use electricity. So what happens here? Electricity is passed through the molten chlorides or oxides of these metals. For example, molten sodium chloride is the ore of sodium. So electrolysis happens there. Electrolysis happens there and we will get sodium metal after this process. Okay, next process is about the process that we use for medium reactive metals. Okay, so what are the methods used? Okay, first of all, let me tell you. In the case of highly reactive objects, most of the ores are chlorides or oxide. In case, and it is very easy. It is very easy for to remove or extract a metal from its metal oxide. You just need to do a process called reduction. If we have aluminum oxide, iron oxide, we just need to do the reduction. So first what we do is, the ores which are in their sulfide form or carbonate form is first made to or brought to, or reaction is conducted, some kind of reactions done, and it is first changed into the oxide ores. Okay, whatever minerals we have, whether it is sulfide or carbonate, first step is that we will be converting it into oxide ore, and after that it is very easy to convert oxide ore into a metal oxide into its original metal by the process of reduction. So this process, the process of converting sulfide and carbonate, is, for sulfide it is roasting. I am writing S in a big letter because it is for sulfide ore. It is that method of roasting is used for sulfide ore. And if it is carbonate, we use a method called calcination. And we will be finding what is the difference between roasting and calculation later in this class only. So, and after this roasting and calcination, the metal oxide that is formed will be reduced. Okay. So that is what is written. So medium reactive metals, mostly zinc, iron and lead, will be found in nature in its sulfide forms, that is zinc sulfide, or in its carbonate forms like zinc carbonate, etc. Iron sulfide, lead sulfide or lead carbonate. It will be in, you will be finding these kind of element in this form. So first you need to do roasting or calcination. Basically it is oxidation reaction and it is converted into oxides. Okay, and then after it is converted into oxides, it will be finally reduced using, might be you will need to heat it, or you might be using reducing agents. We will be reducing it. Okay, that is the case of the second medium reactive metals. So extracted medium reactivity, the metals with medium reactivity is extracted via roasting or calcination, followed by reduction using carbon or just heating sometimes. Okay. The third type is low reactivity series. Low reactivity series like copper glans, copper carbonate and all are there. Copper, then mercuric sulfide or cinnabar we call it. These two are extracted simply by heating. Only heating, or we can also say that by roasting. If it is sulfide, we can use the term roasting for that. Whatever it is, we need to heat it. Heat and heat. Then it will be directly decomposed. Thermal decomposition takes place to form, as it is said over here, to form what? HGO will be continuous heating. It will be converted into metal, mercury metal. And then finally is the refining of metals. Then after extraction, we use, to get pure metals, we use electrolytic refining. So we have learned about all these things. So refining, electrolytic refining is done in the last case. So for metallurgy to happen, or the processes that are needed in are three processes. One is the extraction, enrichment of ore, then comes extraction, and then comes refining. Ores are some minerals which are abundant in nature, easily extractable and affordable. And common ores are given here, and all the extraction is depends upon the reactivity of the metal. And the metal which high reactivity series will be undergoing electrolysis, or they will be undergoing electrolysis in electrolytic cell. The metals belonging to moderate reactivity series, they will be undergoing calcination, roasting, and further reduction. Metals belonging to less reactive series, series, they will be undergoing heating presence of oxygen, and they will be converted straight into their metal compounds. Okay, so let's learn further more about this. For that, we have learned all this chapter. We have finished this. All these reaction we have finished it earlier, and then we will come finally to metallurgy portion. And there are several steps, and the flow chart is shown here to describe the method so that it will be easier for you to find it out. Okay, this is the reactivity series. Extraction of metals. We have explained half of it, and now we will go more deep into it. Yes. So as I have said earlier, if you look at this flow chart, it will be easier for you to understand the method or what are the steps. So metals that is present in high reactivity series will be undergoing electrolysis of their molten ore, and we will be getting pure metals. Metals of medium reactive series, if it is a carbonate. So first, why are we doing it? It is very easy to extract metal from its oxide. So first we will do is that we will convert it into its oxide, and then we will do the reduction. So if it is a carbonate ore, we have got carbonate ore. What will we do? We will do a method called calcination, that is heating in limited or absence of oxygen. Okay. And then another process, if it is a sulfide ore, we will do roasting. Here, roasting means excess of oxygen, heating in the presence of excess of O2. And we will finally get the metal oxide. Metal oxide is reduced using carbon or any other reducing substances, and finally we will get the pure metal, and pure metal is then refined. So metals react on the low reactivity series, again mostly will be sulfides. HGS is an example, CUS was another example. They undergo roasting, they turn directly into metal because the bonds between this is very weak, so that it's a belongs to the low reactivity series, no? So the bonds between the compounds itself is very weak, and thus it gets directly converted into its metal, and then refining is happening. Okay, so then comes, we have already learned about enrichment of ore, and one thing I have to say is that there is a term called GAG. G-U-N-G. What is it? It is the impurity. Ore mined from the earth are usually contaminated with impurities such as soil and sand, and that is called GAG. And prior to the extraction, gangue should be removed. And we also have mentioned some names. One is gravity separation or flotation, or we use magnetic separation for the purpose. Okay. So first we are going in more detailed the reaction or equations that is there for compounds or metals in the low activity series. Okay. Extracting metals belonging to the low in activity series. Which are they? Copper. There will be copper is there, mercury is there, and silver is there. We are going to study about this too. So here we have already said that heating is sufficient. Prolonged heating is sufficient for converting the metal sulfides of copper sulfide and mercury to get copper or mercury in its metallic form. So, cinnabar is the ore of HCS of mercury. When it is heated in air, it first converts to mercuric oxide. We'll not be extracting or we'll not be seeing that metal in between. And mercuric oxide, suddenly it is reduced to mercury on further heating. So let's see. So HGS. And here we can also say that since it is a sulfide or present, then excess of oxygen is taken, then it is also called as roasting, right? So HGS plus O2 is what? HGO and HGO, and also there is excess of so many lot of oxygen is there. So this is also formed along with sulfur dioxide. Then this HGO on further heating, still there is presence of oxygen around. On further heating, you will get Hg, the liquid form, and oxygen. So we need to balance this equation. So 2 HGS plus 3 O2 gives 2 HGO and 2 SO2. So 2 hydrogen mercuric sulfide reacts with 3 molecules of oxygen to give 2 molecules of mercuric oxide and 2 molecules of sulfur dioxide in the first step, and then it gets suddenly heated to HGS and O2. Similar is the case of copper sulfide in nature. It's obtained from its ore by just heating in air. So here what happens is copper sulfate is heated in excess of air. In first case, heat is applied. What happens? Some amount of copper sulfate will be reduced to or oxidized to what? Copper sulfide, copper oxide, and copper sulfate is also formed. Okay, sulfur dioxide is also formed. Then it contains, now in this first step it may contain that whole, we are taking this thing in a whole big bowl of thing, and then these both are heated with excess of air. Oxidation and reduction takes place simultaneously, and we will get, and in between the product, both this Cu2 and Cu2O, both will be present in the mixture. And these two, again on further heating, will be finally reduced to copper and sulfur dioxide. Okay, so this was reaction or extracting of metal low in the activity series. Okay, now then comes the extraction of metals in the middle of the activity series. Here also same thing we have learned. We have said sulfides and carbonates might be present in case of zinc carbonate and zinc sulfate is present. First it is according to the sorry, according to the ore that we take. We do calcination or roasting is done. And finally, we will get zinc oxide. And that zinc oxide is reduced and we will get the zinc metal. So I will read what is written in your textbook so that it will be easy for you to understand. There is explanation of what roasting and calcination is. Okay. Metals in the middle of the reactivity series. So which are they? Yes, iron, zinc, lead, copper. Okay, they are all moderately reactive. These are usually present as sulfides or carbonates. It is easier, I've already told you, it is easier to obtain metals from its oxide as compared to sulfides and carbonates. Therefore, prior to reduction, before doing the process of reduction, these sulfides and carbonates must be converted to metal oxides. The sulfide ore is converted to oxide by heating strongly in the presence of air, and that is called the roasting. In the presence of excess air. Okay, and that process is called roasting. The carbonate ore, shall we use another color? This one. Okay. The carbonate ores are changed into oxide by heating strongly in limited air or in absence of air. And this process is known as calcination. The chemical reaction that takes place during the process is called is as follows. When you are learning it, I want you to learn it properly with all the things in that equation. You should be balancing that equation, right? Okay. So let's write down the chemical equation. ZnX S plus O2. What will it give? We need, what is the product that we need first is zinc oxide, and then remaining will react with sulfur to get sulfur dioxide. So here also excess of oxygen is taken. 2 zinc sulfate plus 3 oxygen gives 2 zinc oxide and 2 sulfur dioxide. Then again, zinc carbonate is heated to form zinc oxide plus carbon dioxide is the one which is given out. It's the gas that is produced. Here it's all balanced. You just need to write down the state. That is also necessary when you write down the chemical equation, right? We have studied in the other class about it. Okay. And then finally, what did you get? We got zinc oxide. So metal oxides are then reduced to corresponding metals by using suitable reducing agents such as carbon. And for example, zinc oxide is heated with carbon and reduced to metallic zinc. So ZnO plus carbon O is used to reduce zinc to zinc element, and carbon monoxide is the gas which is liberated. And this thing You have already familiar with the process of oxidation and reduction, addition or removal of carbon is called as reduction. Sorry, removal of oxygen is called as reduction, and addition of hydrogen is called as also it is called as reduction. Okay, you are familiar with the process of oxidation and reduction explained in chapter 1. Obtaining metals from their compound is also known as a reducing process or reduction process. Beside using coke or carbon, we can reduce metal oxide to metals. Sometimes displacement reaction, you know that, no? Instead of the displacement reaction also can be used. Very highly reactive metals like sodium, calcium, magnesium, aluminium is used. If you what will be happen, we have zinc oxide. A reactive element of zinc an element more reactive than zinc is made to react with a zinc oxide with aluminium. Aluminium is higher in the series, electrochemical series, and thus we can reduce zinc into zinc and we will get this product, zinc and aluminium oxide or whatever it is, it can be converted into that particular oxide using displacement reactions also. For example, if you have manganese oxide, you want to get manganese from this, we are using aluminium is used as the reducing agent. We will get manganese plus aluminium oxide and lot of heat is liberated. Okay, so which is the thing that which is identified, which gets oxidized or reduced? Obviously, you can see there is removal of oxygen over here. So manganese dioxide gets reduced and aluminum is the one that gets oxidized. So we are going to end this class here because it's time, and hope you understood all these things, extraction of metals, the method used, and what the methods that we select depend upon the reactivity series of the elements. All those things we have come across, and it is very important to learn, write the equations down and learn it, and hope it was a fruitful session for you, and thank you so much, and bye.